Okay, moment of truth. Scoot back just a bit here. Alright folks, welcome back to the Zcast. What we are looking at here is an Icom IC-756 Pro III HF or shortwave ham radio. The story is, quickly as I can tell it is, I found this on eBay at half price of what it normally goes for from a seller with low feedback. It was in used condition. If you're not a big eBayer, that means that you get your money back if an electronic item does not fully work. So I decided to roll the dice since I had nothing at risk. I ordered it. It showed up after some fits and starts. The seller created a couple different labels. I was worried that I was being scammed. It did show up. Completely dead. Not a light on the thing. We'll go into some of the symptoms in a little bit. So I contacted the seller, said, "What's up with this?" He's like, "I don't know." And I was like, "Well, I'm sorry, but we can't do business." So I did a item not as described refund through eBay. They approved it very quickly and said, "Ship it back." And this thing is a big old beast of a radio. 25 pounds, 4 rack units tall, something like that, right? Not cheap. So I was like, okay, well, I need a shipping label. The seller was like, "I don't know how to do that." He had 4 feedback, all from buys. So I was like, great. Didn't know if this guy was a scammer or just not well skilled with eBay. So we go back and forth. It turns out the guy's 84 years old. He got this from a friend and he broke it basically. So he was just trying to get something back. So I got my money back. I was like, "Send me a label." He's like, "Can you print a label? I'll send you money for it." And I was like, no. Still got my, scammer spidey senses going on. I was like, "You need to send this." Because it's going to be like $75 to UPS it back to him, right? And we go back and forth. And I was like, "Look, I don't have to send this radio back. You never sent me a shipping label. That's the eBay policy, right? Seller has to provide return shipping." So in theory, I could have just kept this and told him to F off. I didn't want to because Matty Zed's a nice guy. So I was like, "Look, there's 2 things we can do. One, you can ask a relative, ask your daughter or niece or whatever to print a mailing label for this. Here's the dimensions and my address. Give me the label and I'll send it back. Keep all my money. Or I will give you 50% of what I paid," and I even rounded up to $250. I was like, "I'll cut you a check for $250 and keep the radio." And he's like, "So you'll send me a check for $250? I said, "Yes, sir." And we struck a deal. And I felt good about that. I didn't want to just steal the dude's radio because he was just ignorant. He wasn't malicious or anything. So I figured that's the right thing to do. So here we are. I have ordered and received a replacement board that I think is the blown up board on this. We are going to crack it open momentarily, replace that board, see if it brings this radio back, and see if I can end up paying almost the exact original price, $480. The board was $208 plus tax, and then I paid $250 for the radio. 50% off of the retail for a used one in good condition, which is $1,000 to $1,300 depending. So here we go, another adventure, another roll of the dice on the Workbench of Doom here on the Zcast. We'll be right back after I set up. All right, gang, it is time to cook. So here's the big old beast on the bench, and we actually have to get onto the bottom side of this. So we'll flip it over in a second. Now, I would normally be using my nice little Fantic screwdriver here. However, this is a high buck item. That matters because it was made in the nation of Japan. So we will be using instead JIS screwdrivers. This looks like a Phillips, right? Wrong. JIS screwdrivers have a little bit different profile on the bevels, on the tip of the crosshead and stuff like that. They just fit differently. So Japan loves JIS screws. If you ever worked on a Japanese motorcycle, you've also encountered them. If you've ever bought a used Japanese motorcycle, or ham radio for that matter, you have also experienced mangled screw heads. I'm just doing the side screws here off camera. Mangled screw heads from somebody that said, oh yeah, that's a Phillips, I got that. No, it is not a Phillips. It is a JIS screw. And unless you know about this, you're going to just chew up all the heads, especially on anything with a lot of torque behind it. So I am very Eagle Scout about this. I am going to use my JIS driver. Again, 25 pounds on this. Not a monster. I've got some 50-pound radios, but still, it is muscle exercising. Got the 4 side screws here. These anchor both the top and bottom panels. So we'll pop these off. There's no screws on the back. Should be ready to invert. And commence to disassembling. Weird sticker residue there. So 756 Pros are amazing rigs. And there's 3 of them. The first one was a hit. People loved it. It was high performance, had a nice, for the time, very advanced LCD screen. Now it looks quite primitive compared to more modern radios like the super popular 7300 or whatever. But for its time, just ballpark at 2000, 2002 maybe, it was very space age. Strong, powerful, covers HF and the 6-meter band. Very good filters, which we'll talk about in a second. And it's kind of a good full-size radio. At this time in Icom's career, I guess, they didn't have what we'd call a flagship radio, like my big old 7700 or 781. They mostly just had this as the top end rig. So these were coveted by contesters and serious hams, we'll call them, right? Oh, I know what it is. It's the carry handle on the side. 2 screws here. So the 756 is popular. They then did a revision, and the 756 Pro II had a pretty big change in how the signal flows, right? Because these are converting and amplifying and modifying the radio signals in and out. And the big thing about the Pro II was that it went to, for lack of a better term, software-defined filters. So conventional radios, a filter was literally just like 8 of the same frequency crystals hooked up together. And if you know anything about crystals, you know they resonate at a certain frequency. Well, if they're all the same frequency, what happens is you reject everything that's not in that little resonant band and pass the signals you want. And you find crystals that matched within a couple hundred hertz or whatever to build different filter bandwidths, right? So you have like 2.8 kilohertz, which sounds like a telephone. And then you have like 2 kilohertz, which sounds like a crappier telephone. And then you have like 500 hertz filters, which you can't actually hear speech through. It's not intelligible, but it's good for like CW or Morse code. So the Pro II went to software defined, where you could set the width, because it was all done in a DSP. This is the DSP. We'll pop this out in a second. The Pro III basically was an iteration on that. It was more sensitive, better stats and numbers, you know, nerd specs basically. So this is the final and most loved version, the Pro III. What we have to do is get this board out and install it. And I should actually open the box. I have a board guy. I have a guy on eBay that's parts out radios, and I buy replacement boards from him. He's a good dude, and that's where I got the replacement from. So we've got the pants of this thing taken off. I'm going to go open the box, and then we'll get back to it. First, we'll pull this board out. Well, first, we will take a photograph of where all the cables go. Very important. Then we will pull this board out, put the new one in, and see if we have any signs of life. So we'll be right back. Alrighty, it is party time. There's the replacement board. And first we will open her up. So the guy I buy this from, he runs a radio repair business. People bring their radios in to have him fix them. Well, modern radios, you rarely replace a component or two to fix them. You replace a board. People are willing to pay for this. So what he does, he buys a working radio. He pulls it apart into pieces. He immediately, it's like buying a working car and stripping it out, right? He charges that customer the cost of the board that he's set to swap it out, get their radio working once again. And then he sells all the other boards and all the other parts and the knobs and the switches and the case and the power supply and all that on eBay. He turns a profit doing this between the repair costs and the individual board costs. So, here we go. You see he labels things, very nice. And I know that this is the same version and same revision and stuff. I've done a lot of reading while I try to figure out how to work this. So, let's get settled here. And before we do anything else, I'm going to take our other camera. This is my other camera, by the way, that I use. The opening scene was shot on this. It's a little Sony ZV-1 point and shoot. I love it. It's just as nice as the A6700 that I use, that I have up right now above the bench. So I will take a couple photos just to make sure I know where everything goes. That should do it. Let me look at the photos real quick. So that's what I do. I do this because I messed up a radio repair once by not doing that. And I was like, I can figure out where all these go. It took me 3 days. And I had to like pour over the schematics and use a microscope on all the labels and stuff like that. It was hideous. I'll never do it again. So let's take the replacement board, set it aside for the moment, and then we're going to pull off the DSP, digital signal processor. If you like 90s Macs and stuff like that, it uses these very nice connectors right here and here. It's just those two connectors that remind me of the new bus connectors on like PowerPC era Macs. So there's actually not too much going on here. We've got 1, 2, 3, 4, 5 of these ribbon cables. These are just friction fit. We got a couple coax lines. These are little micro coax. This is probably power because it's heavier gauge. And then here at the back, I'm going to just knock this out because I know there's a screw here that screws 2 of the connectors into the back of the radio. And I'm going to forget that. The first time I tore this down, I was like, why is this board not coming out? And then I looked. You got to always look and do a full ocular pat down of the part you're trying to remove. Because though it's usually logical where they have the screws, it's not always obvious. All right, so I'm going to start out. These are just pull-out cables, friction fit. So I have an idea of what happened to this radio, and I will show you. Undo these coaxes. So it's a popular thing to hook these things up to a personal computer for operating digital modes and making little beep boops, right? Start on the screws here. And there's a little port on the back. It's called a CIV port. And I don't know what it stands for, but it is 5-volt TTL serial. If you ever messed with an Arduino or anything, programmed an ESP32, yada yada, it's the same thing. Well, these have a weird design issue. On the input and output of almost every line on this radio, you want to keep the RF out while you allow low frequency stuff in, right? Talking RF, it's like, you know, 2 to 30 megahertz. Low frequency stuff like 100 kilohertz serial bus or analog audio that's, you know, 300 to 3000 hertz. You want to pass that on the wire, but you don't want RF getting back into the radio. So what you do is you put ferrite beads on everything. And on these, this is modern tech. You see there's surface mount stuff and everything. This is obviously not soldered up in a shack, right? This is made in a high-tech Japanese factory. So the ferrite beads on all the logic lines and all the audio lines in and out are very, very small surface mount things, like grain of sand, super tiny. And what happens with this, bear with me, I'm going to open up my new pliers from Harbor Freight. What happens is that when you hook this to a computer, this is a specific problem with that wire and a personal computer. PCs are built like shit these days, my friends. And very often, their ground line, so to speak, like the shell of a USB or whatever, it's not actually at 0 volts. So what happens is when you just take a 5 volt in the ground from the computer, as provided through a USB to serial adapter, you plug it into this radio, there is now a ground differential. It's not really a ground loop, but it's actual like current, like it's juice, right? That runs through those little ferrite beads, which are spec'd for milliamps. Like I said, they're the size of like half of a grain of rice, if that. Those explode. So this radio has no lights, no power whatsoever. There's a power regulator and input board on the side, on the top side of this, on the other side. And when I was first troubleshooting this, popped these little clips off of the devices here. These keep those transistors clamped to this big metal plate here for heat sinking, but they just come right off. What happens is this board can short the 5 volt. And when this board shorts the 5 volt, the radio completely dies because the CPU needs that, various other circuits need it, blah, blah, blah. So I was playing around with this thing and looking at it, trying to figure out what's what. And I noticed on the internet that somebody has said, fixing an Icom IC-756 Pro III. First problem, dead main board replaced. It was shorted. I was like, it can short, huh? So I then did some research and I found the 5 volt regulator on it. I put a voltmeter on it. I was outputting 3.1 volts. So that's not right. But the interesting thing happened when I brushed my hand up against it, against that little 7805 regulator, which is about the size of one of these. It burned me. It was so hot. It was shorted. Something was drawing all the current that it could possibly provide. And I was like, well, that's not good. But upside, that other guy made a reference to that shorting, and he replaced the board and fixed it. So I was like, maybe if I just replace that board, I can bring this thing back. So what I did is the power comes in on one line up on this cable here. So I used my power supply, which I gotta turn on, by the way. And I hooked it up and I watched the current draw. Watching current draws is very important when you're troubleshooting radios. And when I plugged this thing in, it went up to about 12 watts of power draw with the power off. Like no lights, no action on the radio whatsoever. And I said, well, that's weird. So I unplugged this cable, right, to just cut the 5 volts to see if something on this board was shorted. And the current draw went to like 10 milliamps, which is what you expect for a radio that's basically in standby. And I was like, aha. So then I hooked all of the ribbon cables back up. These distribute power to the CPU board and other RF boards and stuff like that. Get in there, tight fit. There we go. And what I noticed is when this was plugged in, no matter what, I got a lot of current draw. With all these other cables plugged in, I saw no change in current draw. Meaning that none of these other boards that connect to this main board, and this is literally called the main PCB for this radio, none of those had the short on them. It was on this. So I was like, I bet if I replace that board, I can bring this thing back. And here's my evidence for what happened. So if we look on the old board, and again, I know it's kind of hard to see, but where is it? Here is that CIV computer control jack. There are little burnt spots here, and there's actually a burnt spot on the metal plate. That part literally exploded off the board when somebody plugged this into a computer to control it. So I talked to my guy. I said, hey, you got a board for this? He said, I sure do. I said, I want that board. So we struck a deal. He usually gives me 5% off or whatever. And here we are today. So I'm going to hook this up. Okay, moment of truth. It's back right side up. I've got a power cable hooked up, and I'll show on my other camera here. I've got it hooked up to my bench power supply, which I will set to 13.2 volts. Sure, that's fine. And please excuse my literal jumper cables. I haven't made a cable for this yet. So what we're hoping for when we hook this cable up on the other camera is a low current draw. We don't want to see like 12 watts. The bottom row is the power. We don't want to see a lot of power getting pulled. So let's hook that up. 50 milliwatts, 4 milliamps idle draw. Perfect. Okay. So now the reflection's funny. Okay. Moment of truth. Scoot back just a bit here. Oh my God. Oh! Okay. Oh, we have sound. The numbers change. Folks, we fixed it. Oh. I can't believe it. That was it. You know what? I'm actually going to kill my overhead here. It gives a nice view of this radio. Wonderful old school, like Y2K display. The screen is in pretty wonderful shape. There's my TS button for tuning step. Go a little faster around. There's a couple dead pixels, which I do not care about. And what you're just hearing here, that's just the natural noise in the radio. There's no antenna hooked up. That was on FM mode, sorry. So this actually has 2 receivers, I think. I'm not sure. I don't know how to work this radio yet. I'll be perfectly honest. I've never touched a 756 Pro before. But what I do know is that it used to not work. And now it does. I'll let you zoom in on the scope a little bit there. Not very high refresh rate. It's not like a 30 FPS thing. It's just meant to see if there's somebody there, right? The meter, though, beautiful. So there we go. It is done, my friends.
9 Victor Foxtrot Romeo 59 into Custer State Park, US 2917. Okay, thanks for Illinois. Have a wonderful evening. KN1TT, QRZ.
Kilo Charlie 4, Yankee Lima Victor.
Kilo Charlie 4 again?
That's Kilo Charlie 4, Yankee Lima Victor. You're 20 over S9 here in Mile High, Denver, Colorado. Over.
Thanks for Colorado. Also a 20 over 9 into US 2917 in South Dakota, 73. KN1TT, QRZ.
Nailed it! A nice example of some board swap level repair on a high-end Y2K ham rig based on a deal gone bad, a lot of Googling, a lot of trawling, like Google groups, archives, and stuff like that to figure out what might be wrong. If you want to click that button to follow my radio repair and operating adventures, I would love to have you do that and also hear from you. Leave a comment if you have any questions or just want to tell a story about your 756. Thanks again, y'all. This is the Zcast signing off. Have a good night.